Math Blast 31, Scaling Factor. Circle the scaling factor in each problem, then fill in the blank to make the statement true, and explain how you know. A scaling factor is a number which scales or multiplies a quantity. So when I look at the first one here, I have 13 on both sides of my relationship. And I'm multiplying this left side by 1 and 999 thousandths. So what we want to figure out is how do those 13s relate when the 13 on the left is multiplied by 1 and 999 thousandths. Since our scaling factor is greater than 1, then the product is going to be greater than that 13 we started with. And so I'm going to say because scaling factor is greater than 1. Now in this next one we have a scaling factor of 999 thousandths. That is less than 1. So right here notice my scaling factor is less than 1. So when I multiply my 13 by a scaling factor less than 1, the product will be less than that 13 that we started with. And again, the reason there would be our scaling factor is less than 1. Now I have 13 multiplied by something is going to give me 13. And if my numerator is 6, then the units I want to be talking about are sixths also, because I need this to be some form of 1 in order to make the 13 I started with equal to the 13 I'm ending with. And so that would be because the scale factor equals 1. We would need our units to be sixths, so that that whole 6/6 would represent 1. Volume word problems. Sebastian's pool is filled with 270 cubic meters of water. The base of the pool is 15 meters long and 9 meters wide. What is the height of the pool? All right, so here I'm going to think of this problem here. I have this rectangular prism style pool. The problem tells me that the volume of the pool, when it says the pool is filled, that's talking about the volume, is 270 meters cubed. And we know the base of the pool has a length of 15 meters and a width of 9 meters. So I'm going to use the formula I know to be able to solve for that pool height. Okay, we know that the formula for volume is equal to the area of the base times the height. Now, here, the area of the base is not given to us, but we can determine the area of the base, because it's rectangular, by taking the length times the width. So, here I'm going to show that 15 meters times 9 meters is what the area of the base would be. And then we're going to have to multiply that by the height, and we already know the volume, 270 meters cubed. So now I want to solve for this h in the equation here. Well, my 15 meters and my 9 meters, let's solve for that. 15 times 9 is going to be, I'll do the work right out to the side here so we all can see that. I have 9 times 5 ones, which is 45 ones. 9 times 1 10 plus 4 more tens is 13 tens. And we were taking meters times meters, so it's going to be meters squared. So here we've solved for the area of the base. It's 135 meters squared. Now we still have this h that we're trying to figure out, and we know that the volume has remained 270 meters cubed. So now to solve for our h, what we're going to want to do is divide by 135. Divide both sides by 135. Or in this case, we could really look at this equation and say 135 times what is going to give me 270. And I know that when I double 135, I get 270. So 2 meters is equal to h. The height of our pool here is going to be 2 meters. Area of rectangles. Find the area of a rectangle with dimensions 3 5/8 inches by 2 2/5 inches. Well, we know that we find the area of a rectangle by taking the length times the width. And so we're given 3 5/8 times 2 2/5. I'm going to convert each of my mixed numbers into fraction form here. So I know that 3, when I'm using units of eighths, would be 24 eighths because each whole would be 8 eighths. So 24 eighths plus the 5 eighths that we have with that 3 is going to be 29 eighths here. Now let's go to our 2 and 2 fifths. When we're dealing with units of fifths, each whole is 5 fifths. So the 2 wholes is going to be 5 fifths and another 5 fifths, 10 fifths. And we'll add in the 2 fifths that's with it, and that's how we get 12 fifths. And so now I can multiply my 29 eighths and my 12 fifths. Let's go on over to the side because I like to show my work here. If I have 29 and 12, I want to multiply these. 29 times 12, there's my numerators. I'm going to use the partial products method here. I'm going to take 2 times 9 ones, that's 18. I'm going to take, and I'll actually put my products over here. And then I'm going to take 2 times 2 tens, so there's 20, that's 40. And then I want to take, that 1 is a 10. So I'm going to take this 1 here times 9 ones. And I'm going to take that 1 here again, which is 10. It's a 1 in the tens place, so it's 10, times this 2 right here. But that's 2 in the tens place, so that's 20. All right, so 10 times the 9 was 90, and 10 times the 20 is 200. So when we add these all up, I'll add all the parts to the product, we end up with 348. And so now if I have 348 as my numerator, I want to multiply those units. The eighths and the fifths gives me 40ths. So I have 348 40ths. Now I could leave it like that. Now we need our units, so we would say inches times inches is what we were multiplying by. So that's inches squared. 348 40ths in terms of inches squared. Or if I want to pull out wholes, because I have 40 40ths that make every whole, I know I could pull out 8 wholes. That would be 320 40ths. And I would have 28 40ths left still. So 8 and 28 40ths inches squared is also a way to represent the answer. Classify triangles. Identify the triangle by sides and angles. In terms of sides, equilateral is a triangle that has all equal sides. Isosceles is a triangle that has at least 2 equal sides, while scalene would be for a triangle that has no equal sides. Looking at the given triangle, I see no equal sides. So I'm going to call this a scalene triangle because no equal sides. In terms of angles, a right angle is an angle that measures 90 degrees, exactly 90 degrees. So any triangle that has a right angle is considered a right triangle. An acute angle measures less than 90 degrees. Triangles that have all acute angles are considered acute triangles, while obtuse angles are angles that measure more than 90 degrees but less than 180 degrees. So a triangle that has an obtuse angle is considered an obtuse triangle. In our given triangle, I see an obtuse angle right here. And so I'm going to call this an obtuse triangle, and we're going to say because has an angle greater than 90 degrees, but less than 180 degrees. All right, classify shapes. Identify each shape by circling each name that applies. Put a star by the most specific name for each shape. So shape 1, a quadrilateral. A quadrilateral is a shape that has 4 sides. This is definitely a quadrilateral. A rhombus is a quadrilateral that has 4 equal sides. It's a parallelogram with 4 equal sides. These sides are not equal in shape 1, so we're not going to call it a rhombus. A parallelogram would be a quadrilateral that has 2 pairs of parallel sides. I see that this top side and bottom side would be considered parallel, and then these 2 sides here, the left and right, would also be considered parallel, so it has 2 pairs of parallel sides. We'll call it a parallelogram. A trapezoid is a quadrilateral that has at least one pair of parallel sides. And so in this case, since it was a parallelogram, we're also going to call it a trapezoid. If it had two pair of parallel sides, then it has at least one pair of parallel sides. A kite is a quadrilateral, and it has two pairs of consecutive congruent sides. In other words, it's a quadrilateral that has some perpendicular diagonals. In this case, our quadrilateral would not have perpendicular congruent sides or consecutive congruent sides that would create those perpendicular diagonals. So it's not a kite. A rectangle is a parallelogram that has four right angles. And here I see there are four right angles in my parallelogram. So this is considered a rectangle. And a square would be, it would need to have four equal sides. So that's not going to be the case. A square has four right angles because it is a special type of rectangle, but it has four equal sides. So the most specific name for our figure would be a rectangle. I'm going to put a little asterisk or star, so to speak, here. Shape 2. Shape 2 is a quadrilateral. It has four sides. It is a trapezoid. It has at least one pair of parallel sides. It is a parallelogram because not only does it have that one pair, but it has two pairs of parallel sides. It is a kite. It has those perpendicular diagonals there. If you take a look here, whoops, our diagonals make those right angles. So we're going to call it a kite there. And we'll see those consecutive congruent sides. And then we also have a rhombus. It has four equal sides. So it's not a rectangle because it doesn't have right angles, and it's not a square because a square has to be a rectangle with four right angles, and it's a special type of rectangle, those four right angles and four equal sides. So now, to end this here, we're going to name the two-dimensional figures in the hierarchy. Starting off, I have a quadrilateral. I'm going to abbreviate here. And then I'm going to have a trapezoid. And then we go to parallelogram. Next would be a rectangle and a rhombus. And then a square. And so before I talk through those, I actually want to go back up because if you look when we go through this hierarchy, the further you get to the bottom of the hierarchy, you're getting to the most specific name. So when we look at shape 2, we said it was a quadrilateral. It has it has four sides. We said it's a trapezoid. It had at least one pair of parallel sides. We said it's a parallelogram. It had two pair of parallel sides. It was not a rectangle. It did not have four right angles. It was a rhombus. It had four equal sides. And it was not a square because it doesn't have those four equal sides with the four right angles. So the most specific name was a rhombus. We're going to put a little star